Today I'm going to take a look inside of this AcuRite brand weather station. This is the outdoor unit designed for a weather station system that also comes with an indoor display. This measures wind direction, wind speed, rainfall, and temperature and humidity. It has a battery compartment that would usually take 4 AA batteries, with a channel selection switch, string to pull the batteries out, and some pins probably for programming it in the factory. Here's the model number. It says DC 3 volts, 4X AA batteries, which implies that 2 of the batteries are in parallel in the battery holder. It also has some screws for adjusting the rain sensor to ensure it records the rainfall accurately. Now I will take a look inside of this. All the screws have fallen out. Let's try and open this. There's some spiders in this, of course. There's a cooling fan with defective bearings. The wind speed sensor has some magnets attaching to a plastic part to detect the wind speed. Probably using some Hall effect sensor in here. And here maybe the temperature humidity sensor unit. And here's the rain sensor, which works I think by water filling up this, tipping this seesaw here, and water fills this, tipping the seesaw back. And this rocking back and forth motion moves this magnet back and forth, probably past a Hall effect sensor. Although, I can hear it clicking when I move it past, so it could be a reed switch. Let's see for the other one. I can hear some faint clicking when I'm moving the magnet past it. Now let's see what's inside this top section with the cooling fan. It should separate. No, it separates from the huge top unit. Here's the fan and the wind speed. Definitely magnets. Although, interestingly, this right side is a magnet, but the left side is not. Maybe it's just some piece of metal as a counterweight. I guess I need to break this top part out. And open. Here's the solar panel that runs the fan, and it's held in this holder. The solar panel connects to this board, which just connects some capacitors in parallel with the motor, which is a normal brushed DC motor. Now let's take a look at the base unit. So I guess this just comes out. This is just a cover to prevent water from getting into electronics. Now we know how it senses the wind. It uses this reed switch to detect when the magnet passes by to record the wind speed. And also on this connector, it even says the pinout with VSS, VDD, SDA, and SCL, which is the connections for the serial interface to this sensor board, which I think is the temperature, humidity, and pressure sensor. Now let's remove the reed switch assembly for the wind speed sensor. And also, this spring right here, I think is the antenna for the wireless signal. It seems unclear how the batteries are wired. There's probably 2 sets of batteries in parallel and those 2 parallel sets in series. You get 3 volts. And to detect which direction the wind is blowing, this seems to be some sort of optical encoder, I guess, with 4 slots, and depending on which combination of slots is showing with this brake beam sensor configuration, it knows which direction the wind is flowing. Interestingly, there's no power cable to LEDs on this side. Instead, one LED, probably infrared, shines into this channel, which has this white piece in here which reflects all the light up. and then it can be sensed by these sensors. And here is the weather sensor board, labeled RH1. And on the other side of this board, there's nothing except for the LED and sensors for the wind direction sensor and the channel selector switch. And on the top of this board, there's the chip under epoxy blob, which I think is the main microcontroller, the crystal, some other chips, some transistors, resistors, those diodes, some other transistors and chip for the radio antenna, some diodes next to the battery connector, most likely for reverse polarity protection. There's a space for an electrolytic capacitor here, but it wasn't installed. Instead, these ceramic ones were installed. Now let's see what's in this enclosure for the rain sensor. It's just 2 wires going to it, so it's probably a reed switch again. And yep, it is another reed switch. I guess reed switches may be cheaper than Hall effect sensors. The screws on the bottom to adjust the rain sensor calibration seem to adjust the end stops of this plastic seesaw with 2 buckets, which senses the rain. And once again, for this, one side is not a magnet, and only this side, where the sensor is mounted, is actually a magnet. But anyways, this is what's inside of a weather station, so make sure to subscribe for more videos.